Okay, we'll begin. I have posted homework 3 and homework 4. Homework 3 is available under week 4, and homework 4 is available under week 6. Okay, so homework 3 covers a little bit of object-oriented stuff, and then a lot of the stuff that we're going to cover today and Friday and even Monday. So today we're going to cover dplyr. Homework 3 covers that. On Friday we'll cover rvest and web scraping, and you'll have some experience there. And then on Monday we'll probably get to regular expressions. So so that's all homework 3. As far as homework 4 goes, homework 4 is just a heavy coding assignment. Okay, you will be coding up board movement for the game of Monopoly, so we can kind of study and see, you know, which spaces get landed on more based on the rules. You already have everything you need to complete homework 4. We've covered reference classes and, you know, just regular old if statements and functions and things like that. And so you can complete homework 4, and I strongly encourage that you start working on it now. Okay, it's not due for almost 3 weeks. Okay, it's due in week 7, but you know, if you wait until week 6 to get started, week 6 will not be a fun time. So you know, and I'll have the TAs talk. I asked them to go over some of the reference class stuff in section, and well, anyway, start looking at it, start thinking about it, start writing some code. Okay, if you break it down into smaller pieces, it's definitely doable. All right, so today we are going to cover Tidyr and dplyr. These are two important functions in the, or two important packages for R. They are part of what we call the Tidyverse. And this guy, Garrett Grolmund, he works for RStudio, and he held kind of a webinar on it a few years ago. And anyway, his slides are really good, so we're going to go ahead and just use his slides. I've linked to the GitHub. GitHub has a preview of it, but I think they only show like the first 50 slides or so. So you'll want to go ahead and click download and open up the slides on your own computer if you want to follow along. Okay, and so so I'm going to go ahead and use these. My name is not Garrett. That was the guy leading the webinar. But thank you, Garrett, for your slides. And today we are going to look at these two packages, Tidyr and dplyr. These are what's known as part of the Tidyverse of packages. Tidyverse is an entire suite of packages. You can actually install. If you haven't done so, go ahead and do install packages Tidyverse. Okay, and this will download and install the Tidyverse packages and things like that. Okay, but you know, we're just going to take a look at two of the packages, Tidyr and dplyr. Okay, there's a cheat sheet. They've actually updated it in the recent years. Okay, we're gonna one thing is the Tidyverse uses what's called a tibble. A tibble is basically a data frame, but it plays a little bit nicely with the console window in that it only shows you know, the first 10 rows or so, and if there's a whole bunch of columns, it's not going to show all the columns. It's going to just show what will fit on your screen. And then there's also capital V view, okay, which allows you to view data sets. So if I say data, say iris, okay, this will load up iris, and if I say view iris, then it pulls it up here, and it looks kind of like a spreadsheet, and you can kind of scroll through and look at the data set like this. This is also what happens in RStudio when you click the data set itself. Iris will actually, you can see the command that it calls. It calls capital V view iris, and it puts it into the window on RStudio, okay? Which is a nice feature, because it used to be the only way you could look at data is to type it out, and it would just dump it onto the console like this, okay? But I think having a interactive scrolling window is quite a nice feature. We're also going to use the pipe operator in a little bit. We'll explain later. Okay. Data wrangling. This is kind of the idea here, and Garrett says he estimates 50 to 80% of your time might be spent on data wrangling or data munging, generative work manipulation. Whether that's true or not, I don't know. But I will say this, is that today we're going to cover Tidyr and dplyr. And dplyr is such a powerful tool that you can do a lot with it. And in fact, I don't know if you guys are going to compete in DataFest in a few weeks, first week of spring quarter. If you compete in DataFest, it's not an exaggeration to say that you can win DataFest using pretty much just dplyr, because it's happened in the past, all right? Because if you have the data and you have a thoughtful question and you explore that question in a thoughtful manner, you can explore it using just dplyr, okay? Because there was a group, they had good questions, they thought about the data, they had asked good questions and said, how are we going to answer this? And in order to answer the question, all they had to do was a bunch of stuff with dplyr, okay? And they did, that was like 99% of the work. They made a couple graphs at the end, but it wasn't the graphs that got them the prize. It was the thinking that they put in and the summary work that they did with dplyr to kind of answer those questions. And they got like judge's prize or something like that, okay? Which is high honor at DataFest. So this is it's a very useful skill and tool to learn, okay? And this is basically what we are going to try to do. We're going to try to reveal information. Tidyr is about transforming the data and getting it into a form that we can work with. And then dplyr is all about revealing information that's in our data. Okay, and so I am not sure if you are familiar with the term tidy data, but that's what Tidyr is all about, okay? We have a few toy data sets: storms, cases, pollution. These are like tiny little data frames that exist. But if you want to follow along, then you can load them up using library EDAWR. EDAWR is not an official package, so you have to install it off of GitHub, okay? Normally, real packages you would call install.packages, DevTools, or some ggplot2. Those are real packages that are on CRAN. CRAN's kind of like the network of computers around the world that allow you to download R. If you have R installed on your computer, you downloaded it from one of the CRAN servers. There's a server here on UCLA's campus, actually. And so you would just, normally you would do this. However, you are able to write your own packages, okay? But if it doesn't kind of meet the bar that's necessary to be released, wide release on CRAN, you can just put it onto your own GitHub, and you can install packages off of GitHub, but you have to use devtool install off GitHub, okay? So you got to run these two commands: devtools install GitHub RStudio EDAWR, okay? If this is your very first time installing DevTools, it's going to download a bunch of stuff onto your machine, okay? Just don't be surprised, okay? But you can go ahead and run this, and then once you've done that, you can do library EDAWR, and it will make these data sets available to you. All right, so here are kind of three of these tables. We've got the storms table, the cases table, and pollution table, okay? And if we look at the storms table, we'll see that the columns, each column is a variable, okay? We've got the column storm name in the storm column, wind speed in the wind column, air pressure in the pressure column, and the date of the storm in the date column, okay? One column per variable. over here in the cases table, this is like the number of cases of some disease, I think tuberculosis, but I'm not 100% sure. If we think about the variables that appear, okay, we have the country where we recorded the cases, and then we have what year it occurred in, okay? But the years are spread across the columns, 2011, 2012, 2013. They get their own column, but that's actually its own variable here. And then the values that we are recording, the count, is kind of spread out along here, okay? So that's the cases table if we look at that. And if we look at the pollution table, we kind of have the opposite problem. We've got city, we've got New York, London, and Beijing. And then for particle size, it says large, small, large, small, large, small, and amount is 23, 14, things like that. If we think about this, what are the variables? One is the city, okay? And then another variable is how many large particles we have, okay? And we have 3 entries for that, and how many small particles we have, okay? And so if we wanted to access these things, when it's each one column is one variable, it's very easy. All you have to do is use the dollar signs. You can say, I want the storm speeds, storm, $ storm, okay? Things like that. I want the storm names. If I want the wind speed, storms, $ wind. This gives you access to those variables. However, when it's not in tidy form, it's quite a challenge to get the pieces of information that you need, okay? So what we want to do is we want to get our data into tidy form, okay? An advantage of having tidy form is you can do vectorized operations. So if you want to say, I want to calculate a variable called ratio, where we're going to take the air pressure divided by the wind speed, we can do that. We can just say storms $ pressure divided by storms $ wind, and it's going to do vectorized operation, 1007 divided by 110, 1009 divided by 45, so on and so forth, okay? These are all possible when it's in tidy form. If it's not in tidy form, trying to do something like that, it's not possible, okay? Or it's a lot more challenging. I don't want to say it's not possible, but it's a lot more challenging. So again, the summary of tidy data is that each variable gets its own column, okay? One column, one variable, okay? And then the rows are observations, okay? Each column is a variable, each row is an observation. Then you have tidy data, right? And then if you've got types of observations, those are all in the same table. If you've got a different kind of observation, it goes in a different table. So tidy data is a good thing, and we want our data in tidy form. Okay, so we have the package Tidyr, and if you don't have it, you can do library Tidyr, and this will load up the package Tidyr. So I'm going to do library EDAWR. This will get our data sets in, and then I'll do library Tidyr. Okay, so this will load up the Tidyr. And there's 2 functions that we primarily use in Tidyr, and those are gather and spread. Okay, so we saw this cases table earlier, and what we have, the issue is that the values that we want are currently shown across 3 columns. Okay, and what we want to do is we want to gather them into one column. Okay, so let's think about this. If we reformatted this cases table into tidy form, so that we're going to have 3 variables, country, year, and n, number of cases. Okay, think about the shape, the size of the resulting table. Okay, so how many columns will the resulting table have? This one should be easy. It'll have 3 columns, right? It'll have country, year, and n. Those will be your 3 columns. How many rows will the resulting table have? It will have 9, right? It will have 9 rows because we've got 9 values to record, okay? And so if we look at this, we've got country, year, and n. And this first value, France in the year 2011 had 7,000 values. Then we have Germany in 2011 had 5,800, US in 2011 had 15,000, and then France in 2012 had this, and we fill this up, and we're going to have 3 columns, 9 rows, okay? And what we have done is we've taken the values that are currently across 3 different columns, and we have gathered them into one, okay? So these values, 7,000, 5,800, 6,900, 7,000, they've been gathered into one, and that's why we call this gather. And so now our data is in tidy form. Each column is its own variable, okay? So that's the verb gather. What gather does is it takes the current column values, 2011, column names, 2011, 2012, and 2013, and they turn them into values down what we call the key column. Then it takes the numbers that are over here, the values over here, and it gathers them into one column here, okay? So let me go ahead and I'm going to call data on cases. And so here is cases as we have seen. And so what I'm going to do is I'm going to run gather cases, and these things, here it says year and n, and we're going to gather column 2, 3, and 4. Those are the columns we're going to gather, okay? And when we do this, it gathers them together, and we get exactly what we see in the on the previous page, okay? On the slide here, okay? The names year and n, they make sense, but they can just be whatever you want, okay? You can say time recorded, okay? And, or I don't know, you can call it annuum whatever. And this will be like number of cases or something. It doesn't matter, okay? These are just text strings, and Tidyr doesn't care. It's just gonna, whatever you put here, it's just gonna make column names, okay? Probably makes sense to use year and n. Let's think, so if I have the cases table, and I do this, I gather columns 2, 3, and 4, this is what it produces, okay? What if I make a mistake and I say gather only columns 3 and 4? What will happen? So this is the original cases table, okay? I haven't modified the cases table. This is the result of gathering columns 2 through 4. This is the original cases table. What would happen if I gathered just columns 3 and 4? How many rows would I end up having? 6. How many columns would I end up having? So what happens is columns 2012 and 2013 get gathered, okay? And the other columns that were not gathered just get repeated, okay? So the numbers in 2011, 7,000, 5,800, 15,000, they just get repeated again, all right? And it feels a little bit strange. So again, here's cases, and if I gather this, this is what I get. But it makes sense if, perhaps if I had different information here. So if I said we're going to create a new column in cases called capital, and this is going to be Paris, Berlin, and Washington. Okay, so here's my cases table, and what I'll do is I'll gather columns 2 through 4. Okay, so I'm not gathering the fifth column capital or country, and what happens there is the columns that don't get gathered just get repeated. Okay, and this feels like this kind of makes sense, right? Paris, Berlin, Washington, things like that. This is what happens here. Is that okay? Why that's happening? Okay. All right. So here's my here's cases table again. What if I gathered columns 2 through 5? What would happen if I gathered columns 2 through 5? So 2011, 2012, 2013, and the capital column. What's gonna happen? Well, it'll do exactly what it says it's gonna do. It's gonna gather all the values and put them in one column. So it's gonna say France 2011 is this, and it does that. And then it also gathered the values that were in the capital column in the 5th column, and it includes it in the same column here. Okay, so now we have not just cases, but we also have Paris, Berlin, and Washington gathered in the thing. Okay, and the column heading just gets put into this key column, which we happen to call year. Okay, is that okay? What's happening here with gather? So that is gather. So what we do, this is the result of gather. Okay. All right, on the other hand, we have kind of the opposite problem over here. All of the values are stored in one column, and what we want to do is we want to spread them across 2 columns, okay? So we've got large particles and small particles all stored in the same column. And so what we want is we want a column for large particles and we want a column for small particles. So how many columns would our resulting table have? Well, we'll have 3, city, large, and small. How many rows will we have? How many? 3. We would have a row for New York, a row for London, and a row for Beijing. So this is what would happen. Here's our things, okay? So New York large 23 gets put into the large column, 14 gets put into the small column. 22 for London gets put in the large column, 16 in the small column, and so on and so forth, okay? So what we've done is we've taken the values in one column and we spread them out across 2 columns. Okay, and the column headings, large and small, they are taken from this key column. Okay, we say look at the column size, and what it does is it then looks at unique values in the size column. So we've got large and small, large and small. There's only 2 unique values here, so it produces 2 columns here, large, column for large, and a column for small. Okay, and then it says okay, and the values are over here, and so it's going to spread out the values accordingly. Okay, so let's go ahead and do that. We'll do data, pull up data pollution. This is what our pollution table looks like. So I'm going to say spread pollution, use the size column and amount, and it does exactly that. Okay, now what would happen if I take this value large and I called it all caps large, okay? So pollution now looks like this, right? If I call the same thing and I say take pollution and spread the values in the amount column out across the columns determined by size, what will end up happening? How many columns will the resulting table have? I think I heard someone say it. 4, right? We're going to have a column for lowercase large and a column for all caps large, because in the size column, which is the column we use for the key, there are 3 unique values. We've got all caps large, small, and lowercase large, okay? So there's 3 unique values, so each of those values get its own column. And what ends up happening is that it will say, okay, Beijing has a lowercase large value, it has no value for all caps large, and it has a value for small. London has no value for all caps large, whereas New York doesn't have a value for lowercase large, but it has 23 for all caps large, okay? So that's what it ends up doing. Is that right? Why that behaves that way? Let me go back and return that to just regular old large, okay? So here's this. Okay, what if I changed it to this, okay? So pollution has city NYC for New York City as this, and then it has city New York, city London and Beijing and things like that. Okay, so if I ran the same operation here, spread, pollution, size, amount, what will end up happening here? How many columns will I end up having? I'll have 3 columns, city, large, and small, all lowercase. How many rows will I have? I'll have 4. I'll have a row for Beijing, a row for London, a row for New York, and a row for NYC. Okay? And it's going to kind of just match up the values accordingly. All right? So for Beijing and London, it had no problem. For New York, it said I don't have a large amount, but I have 14 for small. For NYC, it says I've got the large amount 23, but I don't have a value for small. Okay. So when you use something like spread, and it's trying to use the column, the unique values in the column and the unique values over here for city, it's going to it's going to try to do its best to figure this out. Okay. So anyway, let me reverse this back to New York. It's really weird hearing your own voice talking. I can't even watch. I think that was me, right? It sounded like me. I don't know. All right. It's weird for me to think that you're watching videos of me also. Okay. All right. So this is what we've got. That's spread there. Okay. So spread and gather are inverse operations of each other. Okay. Spread takes the values in one column, spreads them across multiple columns. Okay. Gather, on the other hand, takes values that are currently across multiple columns and gathers them into one. Okay. So they're inverse operations, and depending on the situation that you find yourself in, spread or gather might be, you might want to do one or the other to get your data into the form that you want. Okay. All right, there's also unite and separate. This is less of a big deal. This is more things like if you've got some text string like date and you want to separate it out into year, month, day, you can do that. Sometimes you have things like in serial numbers that get produced. They maybe there's like information in like the first 3 characters of the serial number is like which factory it came from, and the next 4 characters are like, I don't know which machine it came from or something like that. Maybe you want to separate those out, okay? And you got separate and unite, okay? They deal mostly with text things. But to recap, gather and spread, those are the 2 most important functions in Tidyr. Gather takes values that are currently across multiple columns and puts them into one. Spread will take values that are currently in one column and spreads them out, okay? Okay. Now we're going to talk about package dplyr. And dplyr, I think this is one of the most important packages in R. Okay? You'll call library dplyr to get dplyr on okay, and it might say it masks these things, okay? Because this just means we're going to use filter and select and things like that. Okay, so these are kind of the verbs that we'll use. There's a data set called NYC Flights 13. This is also can be helpful to have, and you can load data flights to get flights into your thing. Okay. These are the functions we're going to use, okay? Select, filter, mutate, and summarize. These are the ones we're going to focus on. dplyr has other functions that are very useful, but these are probably the most important ones. And I should say summarize goes along with a function called group by. Group by and summarize, that's, you should throw that in here. Summarize plus group by, okay? Select, filter, mutate, and summarize. All right, select is just a way to select columns, okay? Select is for columns, filter is for rows, all right? That's what you have to remember. Select is for columns, filter is for rows. So if you say select, you can say I want to select from the table storms. From there, I want to select the column storm and pressure, all right? And it will work. So here I've got, if I look at flights, okay, flights comes out as a tibble, and it says there's 336,000 rows, 19 columns, but because it's a tibble, it only prints what I'm able to see on the screen, okay? So over here, if I make my screen wider, it's gonna fit a little bit more. If I change my global options to kind of shrink it down like I normally do on a regular old day, not when I'm teaching, you know, then it will fit more, right? So if I call flights here, it fits 18 of the columns, and down here it says there is one more variable, time, hour, and here it says this, okay? So tibbles are nice in that it only kind of fits what fits on your console, okay? And when you resize it, it's aware, and it will fit only the variables that fit, and it will say these are the other variables that show up. Okay, let me go back, make my screen, blow it up for you guys for visibility. Okay, so anyway, here we are with flights, 336,000 observation, 19 variables. This is what we've got, okay? And you can say, I just want to select from flights, flights, and then you can say I want to select day and, I don't know, carrier and origin or something like that, right? And it does stuff like this, okay? And so select tells you which columns to select, all right? There's a few nice things. You can say I don't want column storm, and you also have this colon notation, which is nice, right? Normally we would just say like 1 through 7 or something like that. But dplyr is smart enough where you can say wind colon date, and it will select the columns wind through date, okay? So on NYC flights, if I do flights, I can say I just want to select flights month through scheduled departure time. Okay, and then it will just extract those columns, month through scheduled departure time, and things like that. There's other things that are really nice. Things like ends with, starts with, these are really handy, right? So you can say, so if I said, well, you know, what are the names in flights, okay? These are all the different column names here, right? And we see a lot of things end with time. So I can say select from flights those that ends with time, okay? And it will pull out departure time, scheduled departure time, arrival time, scheduled arrival time, and air time, okay? Things like, I can say starts with departure, okay? All right, and it'll pull out departure time and departure delay. I think I can do contains departure, and this will pull out departure time, scheduled departure time, and departure delay, things like that, okay? That's pretty nice, right? Okay. So those are select functions to select the columns. All right, if you want to filter rows, we use filter, okay? And this is much like subset. You just say, you know, take this table, storms, now, and I just want where the wind is greater than 50. You can give it multiple conditions. You can say filter storms where wind is greater than 50 and storm name is one of, or is contained in Alberto, Alex, and Allison, okay? And so it'll apply both of those filters. So that's filter, okay? And you just chain them along with commas, and it applies these filters likewise. And I think you guys are all familiar with all of these things like greater than or equal to, is missing, and stuff like that, okay? So, all right, and then you can also create new columns, which is very handy. And to do that, we use mutate, okay? So for example, we could say, I want to create a new column called ratio, where we take the pressure and divide by the wind. So we're going to do 1,007 divided by 110, and we get this. 1,009 divided by 45, we get this. Okay? And so ratio will do this. I'm sorry, not ratio. Mutate. Mutate will create new columns in your data set. Okay? A nice thing is that you can create a new column and use that thing you just created in the same command. Okay? So here we can say take ratio, pressure divided by wind, and then create another column called inverse, where we take the ratio and we invert it and do ratio to the -1. Okay? Normally in R, what you would have had to have done is you would have to create the column ratio first and save that or store that, and then you can reference it after you've stored it and say, I want to create another thing called inverse ratio thing. Okay? Again, dplyr is quite smart, and you can create it in one step. You can say, I want to create a new column called ratio. I want to create a new column called inverse. Okay? When you do stuff like this, though, all right. So if I got the storms table, whoops, this is the wrong one. This is the full one. I want the little one. Let me see. All right, I want EDAWR : storms. Okay, this is the one I want. So if I take this, let me just store this as storms. Okay, so here's storms. If I do something like mutate storms, and we're going to say ratio is equal to pressure divided by wind, and inverse is equal to ratio to the -1, okay? It does this, all right, but you'll notice storms is unchanged, okay? So just like every other function in R, if you want to use the output of one function, you've got to store it somewhere, right? So you can call this, you can rewrite it as storms, or I can call it storms2, okay? And so now I have two things. I've got storms, which is the original thing, and I've got storms2, which is now contains the columns ratio and an inverse, all right? So just like everything else, all of the other functions, you run it, it doesn't alter the original object. Okay? So the thing about mutate functions is that these are called window functions. Because it's going to create a new column, the result of mutate has to have the same number of values. It's got the result of your whatever thing you're going to mutate, okay? This ratio, this inverse, has to be a vector of the same length as the number of rows, right? So this works fine when you do pressure divided by wind, because you're going to get it's vectorized operation. So if you have 6 rows, you're going to get six pressures divided by 6 winds. You're going to get 6 values for ratio. But if you do something like mean takes 6 values and it returns 1. Mean will not work for mutate, because mutate requires a vector that's going to be of the same length. Okay? Things like sum will not work, because sum will take 6 values and return 1. Okay? On the other hand, you can use what we call window functions like cumulative sum. Cumulative sum says the first value is 1, so the cumulative sum is 1. Next value is 2, cumulative sum is 3. Next value is 3, cumulative sum is 6. Okay? In this way, you can give it 6 values, and then the cumulative sum will produce 6 values, okay? Which is necessary for the mutate functions. Mutate functions add a column, which means you need to have a value for every single row. And so the column you're creating needs to be a vector. Okay? If you want to do things like calculate the mean or the median or whatever, these summary functions, then you will use the function summarize. Summarize is a way to say, I've got a bunch of values, I've got 6 values, 10 values, whatever, and I want 1, right? You take the mean, the whole point of the mean is, instead of having to keep track of 1,000 numbers, is you only have to keep track of 1, right? The whole point of your GPA, which is a summary function, is so that we can summarize your entire academic existence in a single number, okay? With all of the negative things that consequences of that, right? But it's, you know, it's for simplicity, right? The true thing we should do is we should look at you as a person, as a whole, and all of that. But I don't know, when you're filling out an application, maybe they don't want to know who you are completely. They just want to know that single number, okay? And that's what the GPA does, okay? It takes an entire person's existence and gives it a single number, which is probably not the right thing to do. But anyway, this is not about that. But that's what we're doing. Summarizing, we're taking a bunch of numbers, boiling it down to one, okay? So to do summarize, we do things like take summarize, and then I want to create a new column called median, where we're going to get the median of the amount, or variance, where I get the variance of the amount, or mean, where I get the mean of the amount, or sum, whatever it is, okay? And so you have that, okay? So summary functions take multiple values and return a single value, okay? And we have things like mean, median, sum, variance, standard deviation. You also have n and nth and number of distinct and first and last. Those are nice things, okay? A range allows us to sort things, okay? Which can be handy. So you can say, I want to sort it by wind speed. If you want it in reverse order, you use descend, okay? Arrange descending wind speed, okay? Descend, actually all it does is it just makes it negative, okay? I don't know if you guys learned that in, for your manual sort function that you did for homework 2, and you wanted, well anyway, I don't know if I did it, okay, well, or the min, the max. But you can just do the negative and you'll get the reverse order here. Okay, we have something called the pipe operator. This allows us to kind of chain operations together. So here we have currently select from storms, storm and pressure. This can be written as storm pipe select storm pressure. So you take storms and you pipe it into select and you say, I want the column storm and pressure. Here is filter. You can say storms filter and do this. And you can chain these and you can say, from storms, I want you to, we're going to pipe this into filter, and this will reduce it down to just wind speeds greater than 50. And from there, we can pipe it into select, and it will just select the columns that we want, okay? You can pipe them into mutate, you can pipe them into all sorts of things, and the command to get this shortcut for the pipe is Command or Control-Shift-M, okay? So let me just kind of show this at work. So here's our pollution table. I can say pollution, and we're going to filter it. So we've got city equals to New York, okay? And then, and so if I do that, then we'll get New York. And then if I say summarize, so if I then pipe that into summarize where I say I want mean, which is going to be the mean amount, then I'll get the mean of 23 and 14, okay? And I can do this and I can say, all right, well, let's filter it where city is London, okay? And we get a mean of 19 because what it's doing is it's just filtering it down to 22 and 16 and gives me the mean of these things, okay? Or if you don't want city as London, you can say size equals large, okay? And did you do something wrong? Oh. I need double equals, okay? Size equals large, and then the large particles, the average of those three numbers is 55.33, okay? This is the most awesome part of dplyr, okay? Right now we can run summarize, and it will take these things, and it will take all 6 values and summarize them down into 42, 252, and 6, okay? But what we can do is we can use this function called group by. And what group by does is it splits this table, and we can say split it group by city, okay? And then it creates basically 3 separate tables. A table for New York, a table for London, a table for Beijing. And then it applies those summary functions, calculate the mean for each of those things, sum and n, and then it combines them together. Okay, so this is the group by function, and it is by far the greatest thing. I got 5 minutes left, so just stay with me here, okay? So we do pollution group by city, and when you run a group by, so here's original pollution, okay? And if I say pollution group by city, it doesn't look like much has changed, okay? This looks almost exactly the same, but there's this little key piece of information that says groups, city, there's 3 of them, okay? And so what this allows me to do is once I've grouped them by city, then I can say summarize, and I want mean equal to mean of amount, okay? And it groups them by city, and it calculates the mean accordingly, okay? And it combines them back into one table. Remember, I did this earlier, but I had to write separate commands. I had to do pollution filter city is equal to New York, pollution filter city is equal to London, and then I could do it also for Beijing. And we could do it this way, but if you had a whole bunch of values, this can be very tedious and annoying to do. All right. dplyr allows us to just combine these 2 things together: pollution, group by, and summarize. Okay, so we say take pollution, group it by city, then do summarize. If I say filter, I want city, not city, not filter. I want group by size rather than city. Okay, then it will do it for the large and the small particles. Okay. This is a very powerful operation that makes our life so much easier by doing this splitting, applying of the functions, and combining them together. Okay, we call this the split, apply, combine, because that's what it's doing. But it does it in one step. Before dplyr, we would have to use lapply and sapply, and those would often crash and break and be annoying and frustrating. Okay, now we have group by and summarize, and it's a beautiful thing. So thank you to RStudio, Hadley Wickham, and the Tidyverse teams, okay? So that's what we have. You can apply hierarchies of groups, okay? So here is just this table where we've got a bunch of information. We've got Afghanistan 99 female, Afghanistan 99 male, Afghanistan 2000 female, Afghanistan 2000 male, Brazil, so on and so forth. And we can say group by first on country and then by year, okay? And what this will do is it will produce 6 groups. We've got Afghanistan 99, Afghanistan 2000, Brazil 99, Brazil 2000, so on and so forth. We're gonna get 6 different groups when we say group by country and year. But it also maintains a hierarchy of groups. So when we say group by country and year and summarize, we're gonna get 6 different rows after we summarize this, because it splits it up into 6 groups, summarizes them, combines them back together, okay? If we said summarize one more time, okay, what this will do is it says it still preserves the country and the year hierarchy, and so even though we've created this table, it can then split it further, group them by country, okay, and there will be three groups then, and it can summarize them and produce this table. So you can apply summarize multiple times, and it will shrink, it will climb back up the hierarchy and produce the things, okay? This is incredibly powerful and incredibly useful for your analysis, okay? So you've got some exercises in your homework that deal with this, and so you can take a look at that. We're not going to cover the joining data. You won't be tested on that, but they are just part of these slides here, okay? All right, well, we'll see you guys on Friday.